Hey guys, what's up? So today we're going to be looking at the segment of a circle. Alright guys, so we're looking at the segment today. Now if we look at this circle here, we can see that there's a chord here, meaning a line drawn at some point from one point to the other point on the circle. And you have a minor segment here and you have a major segment here, right? The big section is called the major segment and the small section is called the minor segment. So it says the segment of a circle is defined by a chord, meaning it has to have a chord like this one here in it. And a chord is a straight line drawn from one point on the circumference of a circle to another point on the circumference. Cool? So if you draw a point from here to here on the circumference, you would create a segment. Okay? You'd create two segments, a minor and a major segment. Okay? So it says normally we have a minor segment and a major segment on the circle. Cool. So the minor segment is here, as you can see that shaded region, and the major segment is all up down here. Cool. Now guys, for most of these questions, all we're going to be trying to find is this segment here, this small area here. So in this example, it would be A, B, C, right? From A to B to C. This whole area right here would be considered the segment, okay? And in this example, this one here where we're just focusing on the segment only, where we have ACB, right, or ABC. ABC, the area of the segment ABC, right, is equal to the area of the sector AOBC, which is A to O to B to C, which is that whole area here. And remember how we find the area of the sector, guys? It's pi r squared multiplied by theta, whatever theta is here, theta degrees, over 360, minus the area of the triangle. If you notice here, guys, that this from AOC or AOB in this example, because it shows here the area of the triangle AOB, there's a triangle here, okay? And these sides are always going to be equal to each other. It's always going to be an isosceles triangle, okay? Because the radius for the circle is always going to be equal. Cool? So to find the segment, guys, this shaded region here, we have to find the area of the triangle and subtract it from the area of the sector. So when we're working out these questions, guys, the first thing we have to do is find the area of the sector, and then we'll find the area of the triangle. And we'll find the area of the triangle using half base times height, or we use Heron's formula. Okay? So a lot of the times, guys, we may need to use Heron's formula, right? Which is A is equal to the square root of S times S minus A times S minus B times S minus C, right? So this is the formula that we may have to use to find the triangle, or we just use half base times height if the angle here is 90 degrees, okay? So if the angle here is 90 degrees, guys, then it would be a right angle triangle, so we would use half base times height. And if it's not, we just have to use Heron's formula. We'll have to use the three sides and find the area of the triangle. Okay, guys? All right, so let's just clear up this right here. And what we're going to do, guys, is we're going to actually do some questions. It's always best to do questions right after we discuss exactly what it is. And I'm going to leave the formula down here so that we should be okay in terms of finding the answer. And we're going to do 3 examples. All right, guys, so let's look at this example here, okay? And it says, given the information in the diagram, find the area of the segment RST, right? Which is RST, which is a small segment here. Cool? And it says the length from R to S is 6.1 and the radius is 4 centimeters. Cool? So the first thing we want to do is we want to find the area of ROST, right? Which is this here. And to find the area of ROST, we need to find pi r squared multiplied by theta, which is 120 over 360. Cool. So we should actually get 3.142. Pi is equal to 3.142 multiplied by 4 centimeters squared multiplied by 120 over 360. All right. So let's just put that in our calculators, guys, and we should find the area of our OST. And let's just put that in our calculators, guys. And the answer we get should be 16.76 centimeters squared. All right, guys. So let's move on. We found the area of that whole section here, right, of the sector. Now we need to find the area of the triangle, okay? So let's just draw the triangle, right? Let's just draw the triangle. And we can see that the radius is 4 here, 4 centimeters. So the other side would also be 4 centimeters because it's a circle. And the top there is saying that it's 6.1 centimeters. Cool. But we don't have the height, okay? We don't have the height of this triangle. So what we actually have to use is we'll have to use Heron's formula, and I have it right down here. So we have to find the square root of s times s minus a times s minus b times s minus c. Cool. Where s is the semi-perimeter. Okay. So let's find s then. S is equal to 4 plus 4 plus 6.1, and this should all be in centimeters. And we're going to divide that by 3. Oh, no. And we're going to divide that by 2. Okay. So S should actually be 7.05. Okay. And 7.5 centimeters. So to find A now, all we have to do is A, which should be the area of the triangle. It should be the square root of 7.05 times 7.05 minus 4 times 7.05 minus 4 times 7.05 minus 6.1. Cool. So let's move this down a bit and let's put that in our calculators, guys, and see what we get for the area. All right, guys, and we should end up with the square root of 91.82 centimeters squared. And let's just find the square root of that, and we should get 9.58 centimeters squared. All right, guys, so to find the answer, all we have to do is subtract the area of the sector from the area of the triangle. So we're going to end up with 16.76 minus 9.58. Cool. And all we need to do is put that in our calculators. And the area for the answer should be 7.18 centimeters squared. All right, guys. So this should be the answer for the area of the segment RST. So the area of the segment RST is equal to 7.18 centimeters squared. All right. Cool. So you see how this one works, guys. You have to find the area of the triangle, and after you find the area of the triangle, you subtract it from the area of the sector. Okay, so we can always find these. Don't make it seem too difficult. All right, guys, it's really not as hard as it seems. Just follow the rules. Okay, just follow the rules and you should be okay. All right. All right, guys, so let's look at the second example here. And it says we can see that the radius is 5. It's a 90 degree angle for the triangle. And it says, given the following information, find the area of the segment LMN, right? Which is LMN, the shaded region. Cool. Now for this example, guys, we can see that this is a right angled triangle. Cool. So if this is 5 meters, this is also 5 meters, right? And let's just draw this triangle for a second. If it's a right angled triangle, right? If it's a right angled triangle, then, and this is 5 meters and this is 5 meters, then we already have the base and the height. All All right, guys, so we don't need to use Heron's formula in this case. Anytime there's a 90 degree in there, guys, you don't need to use Heron's formula. All you need to do is use half base times height. All right, so let's just calculate the area of the triangle immediately. Let's just do that and get it out of the way. So the area of the triangle, so the area of LOM is equal to half base times height. So this is half 5 times 5, and this should be meters in meters, right? Both are in meters. And we should end up with 25 over 2, which is 12.5 meters squared. Cool. So we already found the area of the triangle. Now all we have to do is find the area of the sector. We have to find the area of the sector LOM, right? That whole area here. So let's find the area of the sector, right? And so to find the area of the sector, this should be equal to pi r squared times theta over 360, right? So that should be equal to pi is equal to 3.142 multiplied by r, which is 5 squared, multiplied by 90 degrees over 360. Cool, because it's 90 degrees in that angle there. Cool. So the area we should end up for the area of the sector, the area we should end up with, we're gonna just put that in our calculators. Right, and the area we're gonna end up with, guys, is 19.64 meters squared. All right, guys. So since we end up with this as the area of the sector and this is the area of the triangle, all we need to do to find the area of the segment, area of segment LMN is equal to the 19.64, right, minus the 12.5, and this should be in meters, right? And the answer we should get is 7.14 meters squared. All right, guys. So this should be the answer. So the answer, the area of the segment LMN is equal to 7.14 meters squared. All right. Great. All right, guys. So I usually give you another example, but I'm not going to give you another example in this case. And the reason why is because the two types of situations you're always going to get is a situation where you have a 90-degree angle or you don't have a 90-degree angle, right? So I want you to get familiar with the fact that if you have a 90-degree angle, you can use half base times height to find the area of the triangle. But if you don't have a 90-degree angle, then you have to use Heron's formula to find the answer. Cool. You have to use Heron's formula. And majority of the time, guys, when they don't give you that 90-degree angle, they're not going to give you the length of this side. But if it's a 60-degree angle or a 45-degree angle, they usually give you the side LM or AB, this side here. And when they give you that side, you know you probably have to use Heron's formula. So that's the reason why I don't want to give you another example, because I just want you guys to get used to these two types of questions. Okay. So look in the worksheet. We should have more examples, and I'll see you in the next lecture, guys. I'll see you when we're doing volume. All right, guys. So that's it, and I'll see you in the next lecture. And remember to do your best, and God will do the rest.